Lucy, the most complicated mission yet to visit asteroids. Asteroids, plural. At the completion of its primary mission, Lucy will become the only spacecraft to have ever visited 8 separate deep space objects. It will also be the first spacecraft to ever investigate the Trojan Asteroids, a group of rocks Jupiter has dutifully collected over the last 4.6 billion years into these little pockets ahead of and behind the planet in its orbit of the Sun. Hi guys, this is DK with NASA Spaceflight, and in this video we're going to break down Lucy's mission, its instruments, scientific goals, and what to expect from the spacecraft after the completion of its 12-year mission through the solar system. In late 2014, NASA released an announcement of opportunity for the selection of the 13th and 14th missions under their Discovery program. The Discovery program is designed to select low-cost, deep space missions with the primary goal of researching a specific scientific area in the solar system. Missions such as Messenger, Dawn, Grail, and InSight were, and are, part of the Discovery program. Managed by NASA's Goddard Space Flight Center in Maryland, Lucy's mission proposal proposed a spacecraft that would visit not just one, not just two, and not even just 3, but 8 separate asteroids during a nearly 12-year mission. 7 of the asteroids are Trojans collected at Jupiter's L4 and L5 Lagrange points. And real quick, remember those pockets we talked about Jupiter having? Their proper term is a Lagrange point, which is a place where, quote, the gravitational pull of 2 large masses precisely equals the centripetal force required for a small object to move with them, which is a fancy way of saying that the objects placed in Lagrange points tend to stay there unless a force acts upon them. And this is why Jupiter has been able to collect the Trojan swarms as it has. They stay there once captured there. But we're going to get to more on the Trojans and the asteroids Lucy is going to visit in just a bit. On September 30th of 2015, NASA announced Lucy as the 13th mission under the Discovery program. Over the next 5 years, teams finalized the mission design, and in 2019, Lucy was formally targeted for a launch in October of 2021 on a United Launch Alliance Atlas V 401 rocket. In August 2020, Lucy was given the green light to begin final assembly and testing. This included integration of Lucy's 4 science instruments on its instrument pointing platform for remote sensing science. These instruments are the LRALPH, the LLORI, the LTES, and a high-gain antenna. LRALPH will be used as a color-visible imager and an infrared imaging spectrometer. The color-visible imager, known as the IMVIC, will take standard color images of the Trojans, showing each asteroid's characteristics and activity. The infrared imaging spectrometer, known as LISA, will allow Lucy to see absorption lines on asteroids that show different silicates, ices, and organics that are present on the Trojan asteroids, all in an attempt to show their composition and, critically, where in the solar system they formed before Jupiter grabbed them into one of its Lagrange points. Additionally, Lucy will use its T2 cam to take wide-field images of the asteroids to better determine their shapes. Meanwhile, LLORI is a high spatial resolution visible instrument that will take monochromatic images across the 0.35 to 0.85 microns wavelength, which is to say that LLORI will provide scientists with incredibly detailed images of the surfaces of the Trojans, which will also reveal their subsurface characteristics via impact craters. Complementary to LLORI, the LTES instrument will use an infrared thermal emission spectrometer covering wavelengths of 6 to 75 microns. Having an infrared thermal emission spectrometer will allow scientists to learn more about a Trojan asteroid's thermal inertia, body heat retainment, and surface material structure. The high-gain antenna on Lucy will measure the mass of each asteroid using the Doppler shift of the radio signal from the antenna. To power these endeavors, Lucy features 2 circular solar panels, which unfold from a thickness of 10 centimeters to a full size of 7.3 meters in diameter after launch. Solar panels of this size are needed to help power the spacecraft when at Jupiter's orbital distance. Being so far away from the Sun means we need large solar panels to get enough juice. Additionally, Lucy carries a plaque, aptly named the Lucy plaque. It features many names, quotes, and images that will be sent to space in hopes of being seen by our future explorers. Unlike the Voyager and Pioneer plaques meant for life outside our solar system, the Lucy plaque is meant for our descendants, who may one day rediscover the spacecraft after thousands of years. Assembly of Lucy was completed in mid-2021, and the spacecraft was shipped to Florida in July for final testing and integration before launch. Lucy was moved to a clean room where it was fueled for launch and encapsulated in the Atlas V's 4-meter payload fairing. Lucy was then transported from its clean room to ULA Space Launch Complex 41, usually pronounced Slick 41, at Cape Canaveral Space Force Station and hoisted into place atop the Atlas V in ULA's vertical integration facility. On launch day, the Atlas V will carry Lucy into a stable Earth parking orbit before the Centaur upper stage reignites to place Lucy on its interplanetary trajectory. Lucy will separate from the Centaur 58 minutes after launch to begin her journey to a place where no spacecraft has gone before. But first, she comes back to visit us. Twice. Lucy's unique mission means she can't just go straight to Jupiter's Lagrange points. Her speed and trajectory must be precisely managed so she doesn't just fly by one asteroid and then exit the Lagrange point. To manage this, Lucy will use 2 gravity assists with Earth in 2022 and 2024 to alter its trajectory to intercept Jupiter's L4 Lagrange point first at just the right speed to arc through the point and swing by the asteroids it needs to visit there. While this trajectory might look weird on a space map, it's actually just a heliocentric orbit around the Sun with an aphelion, farthest point from the Sun, at Jupiter's orbital distance, and a perihelion, closest point to the Sun, at Earth's orbital distance. On April 20th, 2025, Lucy will fly past the first of the 8 asteroids on its checklist. The first object is 52246 Donald Johanson. This is not a Trojan asteroid, but rather a perfectly aligned main belt asteroid that Lucy's trajectory just happens to pass while traveling to Jupiter's L4 point. The flyby of Donald Johanson will serve as a dress rehearsal for Lucy's 7 other flybys, similar to how Cassini and New Horizons use their gravity assist flybys of Jupiter to prepare for their main missions at Saturn and Pluto, respectively. In 2027, Lucy will finally arrive in Jupiter's L4 location. Located at the L4 and L5 Lagrange points are these swarms or collections of Trojan asteroids that are trapped by Jupiter's gravity, these pockets that we mentioned earlier. These swarms of Trojans are located 60 degrees ahead of and 60 degrees behind Jupiter. On August 12, 2027, Lucy will fly past 3548 Eurybates, the first Trojan of its mission. Eurybates is a prime target because the 64-kilometer-wide asteroid has a 1-kilometer-wide moonlet named Keta. Other flybys in the L4 location will occur on September 15th of 2027 when Lucy visits the 21-kilometer-wide 15094 Palimili. After this, Lucy will cruise by 11351 Lucas, a 34-kilometer-wide asteroid, on April 18th, 2028. The craft will close out the L4 leg of its journey with the 51-kilometer in diameter 219000 Orus on November 11th, 2028. After Orus, the craft's orbit will bring it back to Earth in 2031 for another gravity assist to send it onward to Jupiter's L5 Lagrange point. There it will visit one, but really 2 objects. 617 Patroclus, and Patroclus is like no other Trojan Lucy will visit. It's a near equal mass binary with Menetius. Patroclus is 113 kilometers in diameter, while Menetius is 104 kilometers in diameter. The 2 orbit each other at a distance of 680 kilometers around a center of mass, called a barycenter, or the point around which they both orbit, and it's outside the both of them. Now here's the best part. The Patroclus-Menetius binary is likely a primordial survivor of the cold classical Kuiper belt, a group of objects left undisturbed from the original accretion of the first stuff of the solar system. This hypothesis, which Lucy will test, is based on Hubble Space Telescope observations of cold classical Kuiper belt objects, more than half of which are known binaries like Patroclus and Menetius. As Dr. Hal Levison said to NASA Spaceflight, quote, "If that's true, then Patroclus is one of the remnants of that really early population that just happens to survive. It's probably extremely primordial, and that's why I think for somebody who's interested in planet formation, seeing one of these things close up, it's going to be cool." End quote. And that last point is actually the reason for Lucy's mission. The answer to the question, what's Lucy's mission all about, is that it's trying to determine how the solar system formed. And that might sound weird given Lucy is looking at asteroids captured by Jupiter. But those asteroids are time capsules. They can tell us from their type where and how they were formed. And they come from different parts of the solar system, having been jostled and nudged by gravity before eventually passing close enough to Jupiter to be captured in its Lagrange points. The types of asteroids in the Trojan swarms are important too. The grayer asteroids, the C-type, formed closer to the Sun, while the redder ones, the D-type, likely formed beyond 20 astronomical units from the Sun, which is to say 20 times the average orbital distance of the Earth from the Sun, where these ices needed to create the red color can survive. What's more, the redder Trojans captured by Jupiter are not as red as their Kuiper belt extended family members. Why is that? That's part of what Lucy seeks to answer, and with that answer could come invaluable insight into how the solar system formed and came to its present state. But what about after Patroclus? Is that really it for Lucy? I mean, kind of, as far as the official mission is concerned, but not really. NASA never throws out a still-functioning spacecraft if its fuel and systems health will allow for an extended mission. While Patroclus will mark the end of Lucy's 12-year primary mission, its orbit at this point will be specially designed to remain stable for the next 700,000 years. While Lucy's systems certainly won't last that long, the craft, if healthy, could be used for other observations of main belt asteroids and objects whose trajectories align with Lucy's. Lucy could be giving us data for years and years to come. Don't forget to subscribe so you don't miss out on any future videos talking about past, present, and future NASA missions. This video was written by Haygen Warren and Chris Gebhardt, and once again, I'm DK, and thank you so much for watching.